Hello and welcome to a video looking at enzyme calculations. I put this all into one video, so we could be looking at rates of reaction, looking at both how to calculate the initial rate and just the overall general rate. We'll also be looking at Q10, which is the temperature coefficient of a reaction. We're going to look firstly at temperature coefficients, and that just refers to the increase in the rate of a process when the temperature is increased by 10 degrees. For most chemical reactions, Q10 is approximately 2, which means that for every 10 degree increase, so if we increase by 10 degrees, our rate would double, but that is just in general, that's not always the case. And the equation for calculating Q10 is the rate at the higher temperature divided by the rate at the lower temperature. So you could put, so we would find, so for example, if the higher temperature we were looking at was, sorry, this is my axis, this is temperature here, and this is my rate. Rate of reaction is measured in S⁻⁻⁴, by the way. So if I had at temperature, I was looking at rate at my higher temperature, if I was looking at 30 degrees and I could read off that 30 degrees was a 50 rate, I would put rate at the higher temperature, so rate at 30 is 50, and then I would divide that by the rate at the lower temperature, which would be 20. So if I read off, I'm going to put that at about 25. So it's basically, our equation is T plus 10 divided by T, so our temperature and then our temperature plus 10 degrees Celsius. So in this case here, I've just made these up, they're not probably not realistic, but Q10 would equal 50 divided by 25, which would be 1.5, I think. Might have to go and double check that. My maths isn't good, I've done it without a calculator. Anyway, so yeah, and so if we look at rates of reaction then, to calculate your general rate of reaction, it is just 1 divided by the time taken for the end point to be reached, which here would be this, because that's the last point on the graph. So this here is my time, and this is my product, so it'd be like this one, I'm just going to say is volume of oxygen in centimetres cubed. So if I wanted to do the general rate, I would have 1 divided by time taken for the end point here, which is 120. So that would be the rate of reaction, 1/120. However, if I wanted to find out the initial rate of reaction, which is like here, I'll just firstly say that the benefit of doing this is because we know the concentrations of each reactant with no product present at this very point, and the rate is the fastest that it can ever be right at the start, because there's more, there's the most enzymes and substrates available, so there's going to be lots of more successful collisions and enzyme substrate complexes formed at that point. And to calculate that, you would do the product divided by time taken. So this would be the product, we've got 50 centimetres cubed of oxygen produced at this endpoint here, and we've done that in 120 seconds. So the initial rate of reaction would be this, 50 over 120, whatever that might be. So you can see how obviously this is a lot quicker than the general one. So that is everything you need to know for the enzyme calculations. Thank you for watching.